As a quick introduction, my name is Tom. I'm the lead Android engineer at Blue Apron. If you haven't heard of us, it means that A, you probably don't listen to enough podcasts, and B, I'll give you a little bit of an intro. We're a home cooking company, and my job at Blue Apron is to help ship the best possible experience for our customers on Android. We actually just launched a couple weeks ago, so it's a very exciting time for us. And of course, that means, we're done with our app, right? Right, you've launched, you're done. So that's kind of the background here, but let's get to what we're actually here to talk about, which is Realm. Quick show of hands, has anyone heard of Realm? Cool, I wouldn't think you'd really be in this talk, if you hadn't at least heard of it a little bit. Is anyone using Realm in their apps? Very cool, all right. So when we started building our app at Blue Apron, we started about a year ago, and I did a lot of digging into different approaches that we could use for caching data, and particularly for offline. We ended up deciding that we would use Realm, and I'm going to do a quick introduction into Realm and talk about some of the good parts that we found and some of the parts that we struggled with, and kind of how we worked around those. Just as a quick disclaimer, I don't work for Realm, so obviously I'm not, here to sell you on Realm, but I will say that our overall experience has been fairly positive with it, with a couple of big asterisks. So let's kind of dive into some of this. What is Realm? So Realm is a new mobile database. The Realm team went out and built a database system from scratch, kind of focused on the mobile use case. The implementation is actually pretty interesting. It's cross-platform, so they built it as a core native library in C++, wrapped with language-specific wrappers. So for the purposes of this talk, I'm primarily focused on Realm Java, because, we're built in Java. But the same concepts apply to sort of whatever platform you're using. Unlike some of the other solutions out there, Realm isn't SQL-based. So the idea is to use your objects to represent your data model, which I know is a totally radical idea, right? You have to design this data model for your app anyway. Why should you also have to design your database schema as well? So let's talk a little bit about some of the things that we've really liked about Realm. There are a couple of really nice things that we've enjoyed. Realm is incredibly simple. We found that getting set up on Realm was actually pretty much as straightforward as it can possibly be. The speed and the tooling support. So Realm setup is pretty simple. If you're using Android Studio and Gradle, which I kind of assume everybody is these days, it's about as easy as possible, right? You add a few lines of Gradle foo, so you declare your dependency on the Realm on the Realm library and add the plugin, then you're basically good to go. You have to set up your Realm somewhere in your project. This is usually going to live probably in your application class. That's the most common place to see this kind of code. You'll need to configure your Realm instance. I'm not going to go into a ton of depth around all of the various things you can do in configuration, but this here is essentially the simplest possible Realm that you can set up, right? This is what we used for development for most of this past year. You'll notice that there's a giant line in here commented with a to-do, which is basically remove this before we ship. That to-do is essentially, hey, every time we change our Realm schema, just go ahead and delete the Realm from the disk. You probably don't want that in your production app, because that would be bad for your users. Then again, if your usage of Realm is just as a simple memory cache, maybe it is good enough to just delete on disk. It's the analog to SQLite OpenHelper. SQLite OpenHelper has this on-upgrade method, and a really common implementation of that when you're first starting your app is just drop tables, right? We don't care, just throw away the data. Once you're in production, you probably have migrations there. Migrations are their own special pain, and I'll talk about those a little bit later in the talk. But while you're in development especially, definitely just use this delete Realm if migration needed. And if your use case allows for it, consider using that all the way through the life cycle of your app. So you've got Realm available in your app, so what's next? Well, in order to actually do anything with Realm, you have to define some objects and their relationship. The standard Realm documentation gives you some examples walking through this with dogs and people and all of that, but because I work at Blue Apron, we're going to talk about food. So let's imagine that we want to build an app that can list out some recipes. I know that's really hard to imagine, right? You can't see why I would be interested in that. I love pizza, so we're going to have a few recipes. We've got a cauliflower pizza, a smoked mozzarella pizza, and a broccoli stromboli, which is basically a pizza that you fold over. Just as a quick plug, these are all real Blue Apron recipes that you too can cook yourself. All right, plug over. All right, so we know our domains. Let's start defining our schema. In SQLite, this is kind of where you would go and you'd define a bunch of tables and your relationships. You'd set up your indices, all of that. In Realm, you just define your data model because the data model itself is your schema. So, well, what do recipes have? We have, some unique identifier from our server, right? You'll note that this has an annotation at primary key, and that's what declares this field as the primary key for that table. That allows you to do, insert or create. It also automatically creates an index for you on that field. We also have a name, an image URL, and then a list of ingredients. A list, this is a list of Realm ingredients, right? Ingredient is another Realm object that we'll define in just a second. And we have, of course, the most important flag of all for any recipe is pizza, right? That's all you really need to know. So ingredients are super simple objects, right? All they have is, an ID, and they have a name, and that's about it, right? They're super basic. So let's get to the cool parts. So imagine that we wanted to find all of the pizzas that we have, in our system. So a query for all the pizzas might look something like this, right? You build up a query that says where it's a recipe and is pizza is true, and then you do a find all. And at this moment in time, the pizzas list has size of 2 because we've decided, right, that we had a cauliflower pizza and a smoked mozzarella pizza and a broccoli stromboli. So let's say that we decide that the stromboli is actually a pizza, right? Because it's basically a pizza. So we're going to create a transaction and we're going to update the field. So we're going to set, is pizza to true. And then at that moment, the pizzas query actually has 3 objects in it. Now, and I say at that moment, I'm hand waving a little bit because there are some mechanics of how that syncs between Realm instances and all that, but I'll cover that in a little bit later. If you're interested in using this in your app, you can register for a listener for when that change actually happens. So you would register a listener on pizzas that says on change, and at that moment, pizzas contains all 3 elements, which is really cool. It's this very reactive style live model. And what's great about that is that makes it really easy to decouple our UI code from our network layer. One of the other nice things about Realm that we've really loved has been the tooling support. So it's fully open source, both the language wrapper and the native core code, which means we can kind of dig in and understand how things work when we have problems with it. The other tool that we've really loved is this thing called the Realm browser. It lets you pull the contents of your Realm off of your device and actually just look at them visually. Which is super useful if you're trying to figure out why is my app not showing me the right data? Is it because the data wasn't stored in Realm properly, or is it because I have a rendering bug? Right? So it's super helpful. So I've told you about kind of why Realm is awesome, but I probably also wouldn't be up here talking about it if the talk was just yay Realm, right? So there's been some challenges. The first big problem that we had was something called partial updates. And by that I mean updating part of an object without touching the values that are set in other columns. By default, Realm doesn't support this very well, and that was a huge problem for us. And I'll talk about why. So let's consider our recipe object, right? So we've got a couple of fields here. Let's imagine that we have an overview screen that shows, a list of recipes, and then a detail screen that, shows you more details about a recipe, right? Fairly standard Android pattern. Let's kind of design our server. For efficiency reasons, we've decided to design our server API with 2 endpoints. We have a recipe list endpoint, and that returns a list of recipes that are overviews, right? It contains their IDs, their name, and their image URL. Because that's basically all you need to render kind of the primary list, right? We don't need to fetch all of those ingredients if we're just showing the overview. Then we have a recipe get, which returns a detail object, which has the ID of the recipe that we're working with, the list of ingredients, and of course the is pizza flag, right? So these endpoints might have been implemented this way for performance reasons. There are lots of good reasons why you might implement a system like this where you don't return all of the data all of the time. So let's walk through what happens when you actually put this into our database. So in a SQL system, right, you would have built out a recipe table. And if the server returned us a list of data, you could insert it into the table and you'd see something, right? So, after we loaded the list of recipes, this is sort of what you'd see, right? Assuming our server returned that data, you'd only populate the columns that you just touched. Then you could insert, assuming that the user clicked on each recipe, right? Like let's assume that the server is going to return the following, and you click on each recipe, that's what you're going to have in your database. Everything's good, right? Unfortunately, that's not how Realm works. And the way Realm works, it would look something like this. After you inserted your details, you would have cleared the things that you got from the overview. And it's because Realm works with Java objects. And unfortunately, when you say, I'm going to create a recipe from this detail object, you can't tell it, this field is set to null by default, versus I explicitly set this field to null in order to clear it out from my data storage. Realm doesn't have any way to actually distinguish those because of the way Java works. In our app at Blue Apron, this was actually a huge problem for us. Because of the way our server API is structured, we do basically exactly this. And we noticed that we were destroying our caches constantly because we were blowing them away. So I'll talk a little bit about how we got around this. Just as a note though, if your server API isn't designed that way, you may have no troubles, right? You may be all set and good. So for us, what we did is we started with JSON from our server. We then convert that into a network model using Moshi, right, or JSON or whatever else you want. And our goal here is to keep the network model as close as we can to the structure of the JSON that comes back from our server, right? Do as little work as we can here and just map it one-to-one, exclude fields we don't care about at all, that kind of thing, right? Once we have the network model, we convert that into client format JSON using a model converter that we wrote. And we wrote an annotation processor to do all this for us, right? It kind of generates all the mapping between different fields and how you put them into maps and all the kind of silly boilerplate, so we didn't have to keep writing that. It basically just maps the fields in the network model into the client format JSON. But it's a really powerful tool because it lets us mutate the structure here. So let's imagine that we have something that's, say, a status, right? The server might return that as a string, but it's more efficient for us to work with it as an int. So at this point, we could convert the string into an int and store that in our database. And the client never has to care about this, right? Like anything in the UI layer never knows that it was a string. It just sees the int. So it's a really powerful model. Once we have the client JSON, Realm actually has a create or update from JSON method, and it uses a JSON parser internally. And there it can rely on the structure of JSON to tell it that if the key isn't present, I shouldn't touch the value on disk, right? A key not being present is very different from a key with an explicitly set null value. So that's how we get around this partial update problem. So we go through this kind of convoluted pipeline, right, of JSON to Java to JSON to Java, which sounds ridiculous. But if you think about what we're doing at each step of the way, each step actually has a pretty important role to play. We've talked about how we can consolidate this and a bunch of things like that, but that's the core of what we're doing. It's a really interesting problem. I'm happy to talk more about specifics, but that's probably for a later talk. So the next big problem we ran into with Realm is orphan objects. So let's talk a little bit more about that. So, excuse me. To illustrate the problem here, let's imagine we've downloaded a bunch of recipes, right? Recipe A uses ingredients 1 and 2, recipe B uses ingredients 2 and 3, and recipe C uses ingredients 3 and 4, right? So if we no longer need recipes A and C, let's say they were from last week, right? They're old. And we want to delete them because we want a free space on our user's device because we're all responsible citizens of the Android ecosystem here. What happens when we delete those from Realm? Well, great. We deleted the recipes, but now we have these ingredients hanging out that have no parents, right? These are just sitting around wasting users' disk space. And over time, they're going to get really annoyed at us. And eventually they're going to go clear all the data on our app, which is going to sign them out. And we're not happy about that, right? If you were using SQL, you could try to solve this by using like foreign keys with cascading deletes, other approaches like that. If you were using a content provider, you could register a listener and all kinds of approaches. There's no equivalent in Realm. So how did we handle it for Blue Apron? What we decided is that we wouldn't do any deletes live. We would do all of our deletes deferred. So instead of deleting while the app is running, we register a task using Job Scheduler. So that looks something like this, right? You register a block of code with your with the job scheduler to run on period, and we mark it to require the device being idle, so that it'll only run when the device is idle, because we don't want it running, while the user is looking at our app. Obviously, your needs for your app of when deletion is appropriate to schedule may vary, right? You can design whatever policy you need. Let's dig into what the Reaper actually does, though. So basically, it's a solved problem in computer science. It's called a market sweep garbage collector. So here's kind of our core algorithm. First, we open a transaction. Then we reset the mark on all the objects. mark the objects that need to be retained, sweep to remove the objects that are marked as not retained, record the timestamp and how many we actually reaped, mostly just for analytics purposes, and then we commit the transaction. And if something fails, we roll the transaction back, right? Pretty basic. So how do we make this actually work? So the first step here is that we have to add a field to all the objects in our schema, which we use as a mark. We used a simple Boolean that we called retain, and we basically just kind of boilerplate copy that into all of our realm objects. That made it super obvious for us. You can use whatever works for you. Once you have a mark as part of your schema, implementing reset and sweep are just totally trivial. Reset is find all the instances, set the mark to false. Sweep is just find all the instances where mark equals false and delete, right? And Realm has great tutorials on queries and all that, so I didn't put a ton of examples on here. The magic of all of this happens in the mark function. And the process of marking an object is conceptually very simple, right? You set the mark field to true on yourself and on all of your children, right? So it's I'm in use, and therefore everything that I require is also in use. So to mark a recipe, you'd set the mark on the recipe and on all the ingredients that it uses. And the final piece you need is a query for all the objects you want to mark for retention. And this is where it gets dependent on your app, right? This is business logic. So maybe that's all objects that are newer than a certain timestamp, or all objects that have a certain value in a certain field, right? Whatever makes the most sense for you. So let's kind of walk through our use case here. So here's the state of the world, right? We have our data objects, and there's some random state, maybe left over from a previous run of the Reaper, right? This field is kind of set to gibberish. So we execute the first phase of the Reaper, right? We're going to reset the mark, and that resets them all to false, right? So at this point, if we were to run the actual sweep algorithm at this point, everything would get deleted. All right, great. So now we're going to go to phase 2, and phase 2 is marking retained. So what we want is we're going to go through and say, okay, what objects are we going to keep? In this case, that's going to be recipe B. So we're going to retain recipe B and its children. And then phase 3, we sweep the objects, right? And now we're just left with the recipes that have, retain equals true. And we're done. How do we keep this actually manageable, right? This could get really painful if we have to remember whenever we add new classes, we have to add them into the reset and the sweep functions. And if we have to write all these mark functions and they have to get updated every time we change our schema, that can get really hard. We use code generation. I'm a big believer in writing as little code as I possibly can, so I write code to write code for me. We built an annotation processor or two to help keep this a little bit simpler. So first, we have this thing that we have these things that we put on every realm object in our system. We have the client contract annotation. And this one isn't strictly required for this process. It just really helps us out a lot. It walks through our realm classes and generates a set of interfaces with constants that refer to the field names. You notice in some of my earlier realm queries, I had to do things like this, where you have this field called name, right? And I have to type the word name in string quotes. That's really painful to search for if you ever want to rename that field. Imagine trying to find something if you had a field called list or something along those lines, right? A field called context, God forbid. Try to find that in your Android codebase. So what client contract does is it generates these constants for us so that we can refer to the fields by some semantic identifier and can actually do refactorings a lot more easily. The second annotation is actually how the Reaper works. So every realm object that we have is annotated with this at user data. And what that does is that lets you specify which field you want to use as your mark. By default, it's just that Boolean called retain. But if you want to change it to be something else, it's totally customizable. It also allows the developer to specify the function for the query. So you can say, hey, here's the query that I want to run. In our case, maybe that's every box that's newer than a certain, or that's older than a certain time, right? Something along those lines. This is usually pretty specific to your objects. So you usually have to write some code here. But a lot of objects don't need a query. As an example, ingredients. In our system, we don't actually care about which ingredients we have on disk. We only need the ingredients that are necessary for the recipes we want to keep, right? So we care about which recipes to keep, but ingredients, you only keep them if their parent says they're kept. And And then finally, the other cool part of this is we use this annotation to generate the mark functions automatically. So because the code generation can actually, inspect the code, it knows what your children are, and it knows how to write code to cascade the mark function down to each child. This is a key piece of making our Reaper actually easy to maintain. So this is an example of some of the code that might get generated to mark a recipe, right? It obviously has some boilerplate, right? But because it's generated code, we don't care. We never have to read this. And it also means that we can move things around in our schema easily. So we're working on getting some of this tooling split out. We don't have it split out from our app yet, but we are planning on kind of, simplifying this out and getting this to a place where we could open source it. So if this is of interest to you, stay tuned. All right, so earlier in this talk, I talked about Realm as a thin Java wrapper over a native core. That model is really powerful, right? It enables a lot of their shared logic to be cross-platform, all kinds of good benefits, but it has some downsides. Notably, it means that you are running native code in your app, even if you didn't write that native code. So it's a bit problematic to have native code in your app, right? If you've ever had to debug a native code crash that wasn't on a device that you controlled, it's really painful, right? Crash reporting tools do various best effort jobs to attempt to get you the information that you need to debug these crashes, but they're not great, right? You get traces that you're like, how did you get to that state? What actually happened? I have no idea. We've only had a very few crashes reported from Realm, but we have had, one or two crashes in the wild. And I think, when I say one or two, I mean one or two issues with maybe 2 or 3 instances. So these are incredibly rare, weird things, but they do happen, right? The other downside of using native code is that it makes your APK a little bit bigger, right? The Realm library is about 5 megs. That's because it has multiple ABIs in it. Each ABI is approximately a meg. But one thing that this means is that you can't use native code in your instant app. If you want to use Realm in an Android instant app, you're kind of out of luck, at least right now, because of limitations of how Google builds and distributes these things. And of course, you probably wouldn't want to use Realm in your instant app anyway, because you have a very tight size budget, and Realm is going to eat almost all of that, right? In fact, because you can't do ABI splits in instant apps yet, Realm would eat all of your budget for an instant app, leaving you with -1 meg to write your code in, right? So if instant apps, like both Realm and Google are working on this, it's something that they're aware of, but if instant apps are an important use case for you, you will have to design your instant app so that it doesn't use Realm. And if you've come to rely on Realm as part of a core of your app, that's a really hard problem. That makes it really tricky. So it's something to think about, if instant apps are like key to your business and they're super important for you, you may need to be a little cautious if you choose to adopt Realm. So how do you kind of get around this? One of the ways you can do it is you can consider an ABI split, right? It's not really hard to do ABI splits. You just need some Gradle. This looks a lot more complicated than it actually is. It's pretty straightforward. I think this is all documented online. And sorry, I've got notifications popping. The most complicated part of this is managing multiple APKs, which can be a little bit of a pain in the ass. And it's not required, because usually the universal APK, it'll work just fine, right? But you're adding 4 megs to your download size that you don't need, and you're wasting that space for your users. So you should at least consider using ABI splits if you're going to use a library like Realm. All right, so one more tricky aspect of Realm, migrating data. So as your schema changes, you have to migrate you have to actually do some migrations, right? It's not a unique pain point to Realm. Pretty much any database system in the world requires you to do this if you actually care about preserving your users' data. But Realm can make it a little bit tricky just because, some of this hiding they do, right? The fact that you've hidden away the fact that you have a schema behind these objects makes it harder to realize the implications of what you're doing in your migration. So let's take a look at an example. So this is a sample migration, right? This is actually drawn from our code base where we had to migrate our servings field from being an integer to being a string. So it looks pretty simple, and it's going to work pretty well, right? We have to add this new field that's a string, then we run a transform to migrate, to copy the value out of the old integer servings field, set that into the new string servings, then you remove the old servings field, and then you rename it, right? Pretty standard stuff for databases. But what happens if we were to decide that, say, Blue Apron should no longer think about recipes? Instead, we should think about products. So I want to do an automated refactor and rename our recipe class to product. Well, okay, the automated refactor is going to work, and it's going to rename, my product.class, right, to something that's going to still compile. This code will still compile just fine. And when I run this, what's going to happen? Well, if I'm lucky, this will crash, right? Because I may or may not have had a product table already in my schema, and that product table may or may not have already had a field called servings, right? So if I'm lucky, this will crash. If I'm unlucky, this will corrupt my data, right? It's undefined, and it's because I used a name in the in the get class field that changed on me. So here are a few tips for kind of running your migrations in a safe way. Always, always, always use strings for your class and field names. That protects you from your from accidental drift, right? Never use a constant that could change out from under you in your migration code. 2, write your migrations as separate functions or classes. If you have just one mega method with a bunch of if statements, it's really easy to mess up the conditionals and end up running the wrong migration. And 3, unit test these, right? Or more accurately, instrumentation test these. Realm has functionality for loading content from an asset file. So you can actually take copy a realm from a particular schema version into your Android tests, and then instantiate your realm with that asset file and actually run your migration in your tests. So this is something that we have where we automatically will run all of our migrations as we grab them. So it gives you a little more sanity that your migration is actually working and doing what you expect it to do. All right. So one of the last categories that we ran into with problems was threading. And Realm is very particular about threading, and it can take a little bit to wrap your brain around what exactly is going on there. So Realm objects are only valid on the thread that they're obtained on. And in particular, they're only valid while the realm that you obtained them from is open. It's a lot like a cursor, right? If you open up a cursor in Android, and then you close it, and then you try to read data from it, well, bad things are going to happen. Similarly, reading data out of a realm object after the realm is closed is a bad thing to do. This sounds like it's going to be really painful, but it's not all that bad. You just open up a realm instance per thread. Opening and closing realms are ref counted, so you can safely open and close multiple times, even in nested use cases, and you're fine. And it's pretty cheap to open up multiple realms. Obviously, the first realm you open up per thread will cost a little bit more, but once you've opened it up, it's easy to keep opening and closing them. It's a minor annoyance, but I guarantee you the first couple times that you are building an app with Realm, this is going to bite you. They have this great in-depth walkthrough, which I would encourage anyone using Realm to read. But let's talk through a place where this actually burned us at Blue Apron. So let's assume that we have a background thread, right? And the background thread is going to do some basic operations. It's going to fetch a recipe from the network. It's going to write the object to Realm, and then it's going to post a callback to the UI thread. So over in the UI thread, we're going to do a few more things. We're going to receive the callback, and then we're going to look for the object in our Realm instance. And that might look something like this, right? You're going to do a query where you're going to find this particular object, which I know is on disk because I just wrote it, right? By the time I got the callback, it's supposed to be on disk. And now I'm going to assert that the object is present. And what's going to happen when I actually run this? Well, most of the time it's going to work. And some of the time, it's not going to work, right? And that's because it's a race condition. So let's let me explain why that's a race condition. So remember when I said that you had a realm instance per thread? So what's happening under the hood in a super simplified version of this, right? You have the state of your world. You have two different realms, one per thread, and they have the same state initially. So we write the data into the background realm, and it's going to change the state to look like this. We have this recipe. The background realm knows about our recipe, but the UI realm doesn't, right? This makes sense. They're on two different threads, right? They have to have some sort of synchronization mechanism. Realm is going to go through this process to notify the other threads and notify other realms that exist and resynchronize them. But that does some work, right? That's going to dive into native code. That's going to notify some watchers across your various threads, and it's going to take some time, right? At the end of it, your data will be replicated in all the places you care about. But that process takes time. So that's why posting a callback to the UI thread triggers a race condition, right? You don't know that the UI thread will receive your callback after it receives realms, or if it'll receive them in the other order. So there is a way to handle this. There's kind of a preferred way to do this in Realm. And the first thing to do is do a query for all of your recipes with the relevant ID. So if you look here, that Realm results class, right? You do the query and you say, find me all of the recipes that have this ID. That'll give you back a list that has either 0 or 1 element in it, right? You can then add a change listener to this, and that change listener will be invoked whenever the contents of that query would change. And once onChange is invoked, you can update your UI, because that's when Realm has actually copied your data between the two different realms, and it's all there for you. And the other cool thing is that you don't actually have to re-query your data once you get onChange. It's live. It's already there. So once you get onChange, the data is already there. You just have to refresh your UI to refer to the new data. So that's pretty much it. I hope this was useful. And if you want, you can find more content from our mobile engineering team. We've got it up on our shiny new blog. And of course, you can find me on Twitter, and I'm happy to answer any questions that you might have.
First off, I think it's really interesting, the code generation. It reminds me of mode generator that they have on iOS for core data. That's super helpful. So I think I look forward to that becoming open source at some point. Obviously, there's probably some work there. For the Reaper you wrote, it seems like that's a lot of work, that it's easy to do wrong, that there might be other ways, and obviously Realm hasn't solved it for us, it sounds like. What other options did you consider? Did you consider like at delete time, looking for all the children and deleting those along with it?
Yeah, so that's a great question. So we talked a lot about a bunch of different ways to solve this. And one way we could have solved it is to build, a delete function for each object, kind of more manually, and do something where it's like, okay, what we'll do is we'll do delete recipe, and I'll run some function that we wrote for deleting a recipe, which also knows to go delete the ingredients. Where that gets tricky is that if you try to do it kind of top down like that, you then have to do backtracking up to see if it's used anywhere else, right? So let's imagine that I wanted to delete, in my previous example, I had recipes, A, B, and C, which shared ingredients, right? And so if I looked at ingredient 1, it's not used by any of my other recipes, right? But ingredient 2 is used by another recipe, so I wouldn't delete it, right? So you have to kind of do that backtracking all the way up the stack, and that's fine in like a 2-level hierarchy. But what if we were 20 levels deep, right? That would mean the delete function would be insanely expensive. So doing it this way, by having it kind of broken out into those multiple phases, made it a lot easier to reason about that, and that made it a lot easier to test. And so the goal of the Reaper was to make sure that all of the work we were doing was in code that we could generate, so that we could write really good unit tests against that and guarantee that the generated code is doing the right stuff, right?
Yeah, so that delete method might make more sense in a one-to-many relationship, exactly, not in a many-to-many.
Right. If your schema is a little simpler, or it's unidirectional, right, then it'll be a little easier for you to write it, something like a delete function.
Two questions. One is, when you do the sweep, does the Realm database compact automatically?
Great question. It doesn't compact automatically. There are bits you can use to tell it to compact. There's actually, when you create your Realm, one of the options that you can use is compact on launch, which will mean that like every time you open up the app, it'll do a little bit of work to compact your files. We don't actually use that right now, but we haven't had enough time to play with kind of what's the right policy around compaction. But it's something that we're looking into.
And the second question is a much bigger one. After all the gotchas and things you discovered, would you do it again?
That's a great question. What I will say is that I've been happy with it so far. I have not had a chance to play with some of the newer tools that are out there. In particular, I haven't tried Vroom, right? I think if I were going through this analysis today, I would have to think about Vroom. And Vroom has some tools in it that help alleviate some of the biggest pain points of SQL. In particular, things like compile time, query verification. right? Like a lot of those things fix the bugs that have given me battle scars over the years from SQL. And that was kind of why I'm like, you know what? When I was writing this, it was in 2016, and I didn't want to write SQL statements anymore because they always cause problems. So I think there are some things that I would have to evaluate, but I haven't had a chance to evaluate them yet. That said, I like what Realm has done for the structure of our app. It means that our code is very cleanly decoupled. We have this UI layer, right, that renders stuff, and we have this service layer that actually grabs stuff from the network and stores it in database. And there's a very, very tiny bit of communication between them. So that core reactive property is really nice. So I think what I would say is, for me, if I were looking at this again, any solution that I would look at, I'd want to have that property and have that be easy to, an easy property to enforce. So I certainly wouldn't use something like just straight SQL, SQL Open Helper. So that would be kind of my metric. I hope that answers the question for you.
Thank you.